Ma'am, they gave velocity, ma'am,
Okay.
and they gave kinetic energy also, ma'am, 25 joules.
Hmm. Okay.
And we need to find the mass, ma'am. First, we need to find mass.
So how can we find the mass?
Ma'am, m is equals to 2 into kinetic energy by v square.
M is equal to 2 into kinetic energy by V square. From where did you derive this formula?
Ma'am, kinetic energy, ma'am. K is equals to half mv square.
Okay. Good, good. Very good.
Yeah, ma'am.
Please wait. Yes. Okay, children, please note it down. You continue the number, whatever the notebook number is there, you continue the number. So now, in the question, the kinetic energy of an object of mass m moving with a velocity of 5 meters per second is 25 joule. So in the question, he has given kinetic energy and he has mentioned velocity also, and he is telling mass m. So he did not mention what is mass. So we need to find out the mass. But once we find out the mass, then what we have to find out is what will be its kinetic energy when velocity is double. So
Ma'am,
here velocity is getting double, then we have to find out the kinetic energy when its velocity is double. One thing that is. And second thing is what will be its kinetic energy when its velocity is increased 3 times. Rishikesh respond. Rishikesh?
ma'am, hello.
Yes, you have raised your hand.
Ma'am, yes, ma'am. I sent project, ma'am, yesterday.
I have seen it. There were no colors, there were no sketches. You wrote with pen, very small letters. I'm unable to read it also. Project is something which you do on a chart with good handwriting, and then somebody should able to read it. Just like a notes or rough book, how you write in a notes or a running notes, if you write the same way in the project and if you send me, then it is not called to be as a project. Project is something which we use it for display purpose. So the way you are sending me, it is not, it is like a rough book. Not only Rishikesh, there are few children who are sending me like this. When we ask you to do a project, when we ask you to do on a chart, it means that it should have some kind of decoration, some kind of good handwriting, some big letters when we display on the wall also, when you stand at a distance also, we should be able to read it, what are the letters. So nothing like that, simply writing like notes and sending me, it doesn't mean like a project. I will not consider it as a project. You are into ninth grade and you don't know how to send a project also by this time. It is the most funniest thing. Okay, for example, a first grade child or a second grade child is not understanding how to write the project, then that's fine. They are small and they don't know. But coming into ninth grade and next year within a month you are going to enter into 10th grade, and how funny it is, like how you don't know how to do the project. Few of you do not do the project at all, and few of you do. Like, 5 to 6 children they have sent me very good. Okay, like I liked it, but few children they have sent like just like a scribbling. Those children I very well who have done like that. So I have already written a reply also. Please send me back again. So please send me back again. And once again, I'm telling you, do it with color sketches, put good border, utilize all the chart space with your letters. Okay, border should be small and writing should be big so that we can able to read it what you are writing on the chart. That's fine. So come back to the question. So this is what the question is. So let us first write down
Ma'am, you
what
did
are
not
the.
give me any feedback, ma'am.
I did not give you what to give also. I did not understood after seeing your project. So I did not give. I was silent. Okay. So next, given values are given v is equal to. Don't do any projects for my sake. I don't want any child to do projects for my sake. Do it for your experience. Do it for your marks. Do it for your knowledge, and do it for your sake. You are just writing like I was insisting you to do, and just writing something, scribbling and throwing on my face. That is not at all fair. I'm not talking about one kid here. There are some kids who are doing the same. I will show to your parents when you come now. So this is the great art of your kid. Please see. I will show to your parent the same thing. So given values are given velocity is equal to 5 meters per second. Okay, mass is equal to, we have to find out kinetic energy is equal to 25 joules. Already it is given in the question. 25 joules. So now we have to find out the mass. So now we are talking about kinetic energy also in this question. So we can use the expression using the expression using the expression kinetic energy is equal to, we have a formula called kinetic energy is equal to half mv square. So now if we want to calculate m here, so this formula can be written as m is equal to m is equal to okay, so this can be written like 2 into ke kinetic energy by v square. So if you substitute the values, so 2 will be common. Kinetic energy is 25 and v square means velocity given is 5. So 5 square. Okay, so if this is cancelled, answer is 2 kgs. So 2 kgs is mass now. Okay, completed till now, huh, children?
Yeah, ma'am, completed.
Yeah,
You
ma'am.
complete, I'll move the board. Please complete it. Okay, so hope you have completed. So now, right. So now in the question he is telling what will be its kinetic energy when velocity is doubled. And then first of all, we have to find out the kinetic energy when velocity is doubled. So when velocity is doubled, when velocity is doubled, so velocity is actually in the question he has given velocity 5. But now we have to double the velocity. So 5 plus 5 is v is equal to 10. Okay, that is the meaning of velocity is double. So in the question velocity is 5, we have to double it. So it is 10. Okay, so then if I substitute again, kinetic energy formula is same. Okay, so Ke is equal to half mv square. Okay, so same like if you substitute the values, what will you get? Half into mass is 2 into 10 square. Okay, so this answer would be
100, ma'am.
around 100. Yes, 100. Okay, 100 joules. And one more thing is there, when velocity is tripled. What is the answer when velocity is tripled?
Ma'am, 225.
Yeah, 225 joules. Right. So next case is when velocity is tripled, or it is made into 3 times. So 5 into velocity given in the question is 5. So 3 triple means into 3. So 5 threes are 15. So it is 15 meters per second. So then same formula we apply. So K is equal to half mv square. So half into m is 2 again. So 15 whole square. So same again, the answer will be around 225 joules. Note it down.
Yes, ma'am.
Everybody understood this sum?
Yeah, ma'am.
Yeah, ma'am.
So these are all model sums, Nana. So in the exam, he may ask you in any way the question. Okay. So whatever the possible models in exam he may ask you. So all those models I was just trying to teach you so that if there is some kind of logic involved or numerical changes there. So in the exam also you can read the question twice, thrice, and then you can slowly apply your formulas and get the answer done. Okay. And there are few questions like a kind of theory questions, but they are important and they are logical also, and they'll be coming in the exam. Have you completed this?
Yeah, ma'am.
Please note down the next question. Next question. What will cause what will cause greater change? What will cause what will cause greater change? Greater change. What will cause greater change in in kinetic energy, kinetic energy of a body? What will cause greater change in kinetic energy of a body? Changing, changing its mass, continuation, changing its mass, changing its mass, changing its mass, or or changing, changing its velocity, or changing its velocity? Question mark. So read the question now. So what will cause greater change in kinetic energy of a body? So if a body is, there is some network issue here, and that's the reason it is just dropping. Class is getting dropped. So I'm audible, I think so. Now,
Yes,
so
ma'am.
please tell me the answer.
Ma'am, can I say answer?
Who is this? Siri? Please tell me. Yes, Siri, please tell me. Siri, are you there? Am I audible? Somebody please respond. Am I audible?
Yeah, ma'am. You're audible.
Then what happened, Siri?
Ma'am, I said, ma'am.
I cannot hear
Ma'am,
anything.
kinetic energy is directly proportional to mass, ma'am, and velocity, ma'am. That's why changing the velocity will be cause greater.
Yeah. Ashwit, mute yourself. Yeah. So very good, Nana. Very good answer. So this is a question where you have to read it logical. I mean, it is a It is a fact based question. So what will cause greater change in kinetic energy? If a body is in kinetic energy, okay, if a body possesses kinetic energy, so what will cause greater change? Means we can increase the kinetic energy or we can decrease the kinetic. Change here is nothing but increasing the kinetic energy or decreasing the kinetic energy. So which factor plays a major role in changing the kinetic energy? It could be increasing the kinetic energy or it could be decreasing the kinetic energy. So what plays the major role? So that is the question here. Okay, so the answer is changing its velocity. So when we increase the velocity, obviously the kinetic energy will increase. When we decrease the velocity of an object, obviously the kinetic energy will be decreased. So the answer is changing its velocity. Please note it down, changing its velocity. Answer is changing its velocity.
Yes, ma'am,
Answer is
completed.
changing its velocity.
Yeah.
Next question is, when is when is when is 1 joule of work, 1 joule of work, 1 joule of work said to be done? 1 joule of work said to be done. When is 1 joule of work said to be done? When, children? When we can
Ma'am, when
say,
is the work done?
yeah, when we can say 1 joule of work is done. So how to define it? If I say here, okay, on this object, 1 joule of work is done. If I'm telling there is a table, and if I say 1 joule of work is done on this table, so what does it mean?
Ma'am, can I?
Ma'am,
Yes,
can I?
Abhinaya. Abhinaya, please tell.
Ma'am, yeah, ma'am. Ma'am, 1 joule is the amount of work done on an object, ma'am.
Okay,
When a force of 1 Newton is displaced by 1 meter, ma'am.
very good, excellent. So when we can say 1 joule of work is done when when a force of 1 Newton acting
One
on a
Newton.
body. Okay, so when a force of 1 Newton is acting on a body and the body is also moving. Okay, I mean the body is displacing. The body is moving because you are acting some force on it. How much force you are acting? A force of 1 Newton. You are acting, I mean you are acting of a force of 1 Newton on a body, and the body is displacing or the body is moving in its own direction. Then we can say like 1 joule of work is said to be done. This is an important question. Okay, this question is repeated in CBSE exams. That's the reason I was just explaining you. So please note it down. Answer is answer is when a force of when a force of when a force of 1 Newton, when a force of 1 Newton, when a force of 1 Newton, 1 Newton acting on a body, acting on a body, acting on a body, displaces,
Ma'am, can you repeat once again?
yes, when a force of, when a force of 1 Newton, 1 Newton, 1 Newton acting on a body, acting on a body, acting on a body, acting on a body, displaces Displaces. 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 Displaces in its. Displaces it. Displaces it. Displaces it in its own direction. 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 Done, everybody?
Yeah, ma'am.
Yeah,
Okay.
ma'am.
Next question. Next question. When is works? When is work? When is work said or said? When is work said? SAID. Said to be done. When is work said to be done? When is work said to be done? Against. Against. Against the force of gravity. Against the force of gravity. Against the force of gravity. So what is the answer?
Ma'am, when the object is raised to a certain height, ma'am.
Okay, why? What happens? What is the what happens when an object is raised to a certain height? Okay, what
Ma'am, the
happens?
work is said to be done against, ma'am, to the force of
Against the
gravity.
force of gravity, because
Force of gravity.
when you raise an object to a certain height, or when you lift an object to a certain height, so it is against the force of gravity. So you are lifting above. Okay. Okay, so it is against the direction of force of gravity. So that is the reason we say work said to be done against the force of gravity when a body is lifted. Okay, when a body is lifted to a certain height. Okay, answer is, note it down. Because we are lifting here against the force of gravity. Force of gravity is there on the earth. You know, force of gravity is nothing but gravitational force. So we have gravitational force on the surface of the earth. When we lift objects against the force of gravity, I mean when we lift the objects to a certain height, then it is called as work is done against the force of gravity. So answer is, when a body when a body is lifted, 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 the work is done, the work is done, the work is done against, the work is done the force of, against the force of gravity, against the force of gravity, against the force of gravity, against the force of gravity. So for this Saturday GA, okay, you have whatever the important model questions I told from all the lessons. Okay, from last week onwards, I was telling you important model questions for your CBSE annual exams. So can anyone tell me how many questions I've completed as of now?
Ma'am, 37.
41, ma'am. 41.
41.
Yeah, ma'am.
Okay. So this 41 questions, okay, if few more are added today and tomorrow also, I think it would be around 50. So this 50 questions is the syllabus for your GA. Saturday you have graded assessment, na? So for that Saturday GA, the syllabus for physics is the 50 questions. I will be completing the remaining 41 is there. So today and tomorrow combined together, definitely we'll complete another 8 more. So definitely it would be around 50. So that 50 questions, important model questions. So I here you have to find out one point is, understand one point is the questions are not given from one particular chapter. So I have given questions from force, work and energy, laws of motion. So motion chapter. So there is a combination. Whatever the important questions are there from each and every chapter, all those questions I have explained. So from this 50 questions, you have to prepare for your GA. Okay, from this 50 questions only, I'll be preparing the question paper also. So maybe some kind of numerical changes are there or some kind of logicals are included, but this 50 questions you have to prepare well. So this is the syllabus for your GA also, right? So now next question, please note it down. Next question, please note it down. And already unit 4 syllabus I have told you very clearly. Unit 4 syllabus, work and energy. Okay, work and energy chapter from your physics textbook, work and energy chapter is for your unit 4 syllabus. And in that also, whatever the important model questions I have added from work and energy chapter, that will also be considered, okay, included. So work and energy chapter, you have to read in text questions, in text problems, exercise questions, exercise problems from your textbook, and important model questions from your notebook related to work and energy chapter. This is the syllabus for unit 4 exams. Right. Note down the next question. So write an expression, write an expression, write an expression, write an expression for the work done, for the work done, write an expression for the work done, for the work done, for the work done in in lifting, in lifting a body of, a body of, body of, in lifting a body of mass m, mass m through a, through a vertical height, vertical height, through a vertical height h, through a vertical height h. This question is given for CBSE exam 2012 year. So body of mass m through a vertical height h. So what is the expression, children, in this question we use?
Ma'am, can I say?
1 minute. Let boys also try. I think they are sleeping in the class. Boys not there? Anyone from boys, please explain this question. Anyone from boys, please explain this question. You did not understand the question. It mean like boys did not understand the question. Very easy expression. It is not any difficult kind of expression. Srijan
Ma'am,
respond. 1 minute. 1 minute. Srijan respond. Srijan. Srijan respond. Srijan respond.
Ma'am, can I?
Yes, who is this? Aditya.
Aditya, ma'am.
Please tell.
Ma'am, MGH, ma'am.
So MGH. So what is full mean like work done is equal to work done is denoted by W.
Yes, ma'am.
Okay, so W is equal to
Force into displacement.
so W is equal to MGH.
Yes, ma'am.
Okay, so why? How did how did you get it?
Ma'am means
What is the
when a
concept?
body of mass M is lifted to a vertical height of h, the force acting on the body is force of gravity. The force is driven by F is equal to W is equal to mg. So work done is given by W is equal to mgh.
Mhm. Okay, so actually you can also understand in this way. Here the object is or the body is lifted to a certain height. So whenever an object is lifted to a certain height, after reaching to that certain height, the body comes into resting position, and the object the object will possess potential energy there. So here we have an expression for potential energy. PE is equal to mgh. So as the object is in potential energy form, hence we will say that work done is equal to potential energy. So work done is W. So W is equal to PE. So PE is equal to mgh. Hence we will say work done W is equal to mgh. Here G is nothing but acceleration due to gravity. So your concept is also correct, Aditya Naidu. Good. Well tried. So note down the answer. Work done. Work done. W is equal to mgh. 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 Where G is acceleration due to gravity. Where G is acceleration due to gravity, where G is equal to acceleration due to gravity.
Yes, ma'am, completed.
Where G is equal to acceleration due to gravity. Okay. Next, note it down. Next question. Name 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 three commonly name three commonly. What is your period break time, children?
11 months, 12 months.
12. Okay. I think it is 11:55 to 12:10 actually, what I think is. But anyways, now with this question I will end this class.
Okay, ma'am.
Okay.
So name three commonly used units of energy. Name three commonly used units of energy. What are the three commonly used units of energy?
Ma'am, watt, kilowatt.
Hmm?
Ma'am, watt, kilowatt and kilowatt per hour, ma'am. Or
Okay.
units.
Okay. You can also write joule. Okay, note it
Yes,
down.
ma'am.
Joule. Joule. You can also write erg. 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 Joule. Joule. Erg. 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 Kilowatt hour. Kilowatt hour. Kilowatt hour. Right, so after, I mean, before ending the class, last thing is, please send me your notes. All these 41 plus 1, 42 questions of notes you have to send me for correction. Those children who have
Ma'am,
already
40
sent me,
questions, ma'am.
okay, yeah, whatever it is, 40 or somewhere around. So whatever the questions I have told you in this week, few students are sending me, I really appreciate them. But those who have not sent me notes for correction today, at any cost you have to send me your notes for correction. Otherwise tomorrow in the class I'm going to question you, and I'm going to talk to you. If you are not still sending, I want to talk to your parents also. So please send me your notes, and I'll be waiting for your notes. Have a nice day. Homework is, please prepare for your GA. All these 40 questions, prepare well for your GA. Right? So have a nice day. Thank you very much. Okay.
Bye, ma'am. Thank you, ma'am.
Bye.
Ma'am,